Okay, so thank you for joining the community call, the Dapper community call. As always, feel free to use the chat or ask to be unmuted by raising your hand. We have a pretty packed agenda, and I will share my screen to show it. One more second. If you can see it. So, assuming you can see my screen, we'll very shortly kick it off with Yaron demoing the bulk get API. And he also will be showing some CLI new features and improvements coming in. A lot of the stuff we're going to show today is stuff that's coming in 0.10, which is the release that's due to come out later this week. Leon is going to show a pretty major effort around MultiPubSub. And then we got a few presenters, Yangbu, Pruthvidhar, and Mark, showing some SDK improvements for Python and Go. And lastly, I'm gonna show some changes we made in the samples recently, which we kind of gave a heads up in a couple of community calls earlier. So we have a pretty packed agenda. Looking forward to getting questions and feedback from everyone. As always, as I mentioned, use the chat, raise your hand to be unmuted. And with that, let's let Yaron take it away.
Thank you, Ori. Let me share my screen and let me know when you can see it.
Yes, we see it.
Okay, great. So let's start off with the new addition, a new API addition for Dapr 0.10, which is the bulk get API. So whether you know it or not, Dapr has this stateful API, which gives you an abstraction and some added features across multiple different databases or state stores. And you can get state, you can publish multiple items, you can get an item, you can delete an item. And what we've heard was, hey, it's not uncommon for me to have a list of keys. And instead of, if I have a list of 1,000 keys, I want to be able to give that list of keys to Dapr. And instead of calling Dapr 1,000 times, I just want to call it once. So we came up with a get bulk API. There was an issue for it, which you can search under bulk get in the Dapr repository. And this thing is pretty simple. So what I'm going to do is use the Dapr CLI. For those of you who don't know, the Dapr CLI is a developer-facing tool that helps us run Dapr locally or in a self-hosted environment, for example, like a bare metal VM type of environment. So I'm going to run Dapr, and I'm going to do Dapr run, and I'm going to give it an ID. So this thing is just running the Dapr sidecar. Usually, you see us using Dapr on, and then I can give it some arguments which run my app. And what the Dapr CLI will do is it'll boot up the Dapr sidecar and then boot up the application. This time, I will be pretending to be the application using Postman, so just regular HTTP calls to the Dapr sidecar. So I'm just running the Dapr sidecar here over port 3500. So I'm going to launch this. And Dapr is up and running. We can see the logs here. And if I go to Postman, I can see that I'm going to save some state. So this is the Dapr Save State API, which accepts a list of items. So this is the most simplistic way. You can also bring in consistency options like strong consistency or eventual consistency, and first write wins or last write wins. But for now, just for this example, I'm just saving a bunch of keys with test 1, test 2, all the way up to test 5, and contacting Dapr over localhost with the state API and targeting state store. So when I install Dapr locally, it installs a Redis instance, which is identified with state store. And when I run Dapr, I can give it any sort of component YAML that'll point me to the state store of my choosing. And so this is pretty simple. So I'm just going to post that, and we can see that we have 201 created. So I created all those items. And if I wanted to get all of the items, what I would need to do up until 0.10 was to have like a for loop in my application, which would call Dapr for every single key, which is kind of not very latency sensitive. What we're introducing from 0.10 is this API where I'm calling the Dapr sidecar with a bulk operation. This is post because we have a body. So there is a simple JSON here. And you can see that I have keys. So now I'm basically telling Dapr, hey, return all those values for my keys. So I'm just going to send this. And I got a response back. And we basically got a list of keys. Now, something else that you can tell Dapr, for example, in this case, is the amount of, or actually the threshold for parallelism. So we're looking at Dapr, becoming more and more this library as a sidecar with APIs. So it's natural that its APIs will look more like something that you'd get from an SDK that you're having inside of your application. So what you can tell Dapr, for example, is this thing. And now I'm basically telling Dapr, hey, when you're calling the state store, I want you to hit it only once for every one of those operations concurrently. So I'm gonna fire that up and we can see this took a little bit longer, 14 milliseconds. Of course, if I switch that to 5, we should be getting lower latencies. So Dapr itself will not reach out for a bulk get for the underlying component. So your application only needs to call Dapr once, and then Dapr will manage those calls. So for example, if we have 5 items here, Dapr will call the state store 5 times, and you can configure its parallelism here. In the future, we can also extend the interfaces that we have between Dapr and the state stores so that we can actually do a bulk get all the way for the state store that's supported. So currently this feature is actually implemented for all of the Dapr state stores. And this really reduces latency by a bunch for very large amounts of items. And that's it, basically. So shall we open it up for questions now, Ori, or do you want to continue?
That's a pretty cool demo. If anybody has questions about the bulk get, feel free to drop them in the chat. If not, we can move on to the next topic, which is the CLI. So I don't see anything, but we'll have a Q&A at the end as well, so we can always come back to this.
All right. All right, so moving on, the Dapr CLI. There's a bunch of changes here coming up. We're working quite heavily on the CLI. And a few things that we changed, for example, was the getting started experience on Kubernetes. If you've used Dapr until now, you know that we recommended to install Dapr using Helm. And well, that's still true because with Helm, you get I think the largest amount of configurations that you can do by the virtue of Helm parameterizing everything. But we've completely redone the Dapr init Kubernetes command. So for example, now you can do stuff that you couldn't do before. For example, tell Dapr to which namespace you're going to install Dapr to using Dapr init. Up until now, you could only install it into the default namespace, which kind of sucked. You can choose it, and then default is just like that namespace is really becoming like this place where everyone just packs their stuff. So by default, Dapr will now install into Dapr system. You can also do things like enable TLS. So for example, if you are running a service mesh that's already doing TLS for you and you want to turn it off, you can just do enable TLS false. And another really nice thing, cool feature that you'll also find in our Helm chart is enable HA, which is not enabled by default. And if you do enable HA true equals true, it will run the Dapr control plane in a highly available manner, which is the recommended setting for running it in production. If you tuned in on our last community call, we basically showed you the document that we have for production readiness, where we recommend running Dapr with the highly available mode. So that's also configurable via the CLI. So I'm just going to install Dapr now, and you can see that if you saw it before, we removed the note saying this is only for testing purposes. So this will basically install Dapr, and now we can use the CLI to check for the status. So I can do something like Dapr status -k, And we can see that Dapr installed successfully. It's aged at 11 seconds, running the 0.9 control plane inside of the Dapr system namespace. So also, if you tuned into our last community call, or if you've seen the production ready guide, you know that up until now, to upgrade Dapr required you to uninstall completely and then install Dapr, and that meant downtime for your app. Well, Dapr now supports 0 downtime upgrades. And the way that we do that is a combination of the highly available mode and then using Helm upgrade. So I showed this last time, no, not this guy, Helm upgrade. This will basically update the Dapr version from the existing chart to a new chart. And I basically showed that we need to bring in our TLS certificates because Helm will just bash everything away. You can't tell Helm, keep it, and it'll just bash it away, and you need to bring it. So I started off from here, and I didn't really show you what you need to do in order to get the Dapr certificates. And that's kind of, I would say, involved, because you need to get the Dapr secret. So you need to find the Dapr secret called Dapr Trust Bundle for the namespace that you're running in. And then, yeah, it's not Dapr Test in this case, it's Dapr System. And then after you get the certificates, you basically need to take each one of those values, base64 decode it, and then save it to a file. But now you can do just something like this. You can do Dapr MTLS, export, and give it an output folder. And what it'll do is it'll just save it, save your certificate so that when you do Dapr upgrade with Helm, you can just pull in those certificates. So this really saves a bunch of work for you. Another thing that we've heard is, hey, I have Dapr rotating automatically my workload certificates for mutual TLS, but what about my root cert? And how do I know that it's gonna expire? Which is a pretty good question. So now you can do Dapr MTLS expiry. And this will actually give you the exact date of when your root cert expires. And this one expires in 8,759 hours. So you can embed this stuff into your processes. So those are some of the things that are coming out with the Dapr CLI. So the ability to check for the expiry of the root cert, export your certificates so that you can easily upgrade Dapr, and then the check out the new flags on the Dapr init because it supports custom namespaces, highly available mode, and installing Dapr with and without TLS. Yeah, and I think that's it. If there's anyone here from the Dapr core team who wants to chime in on a few other CLI changes that I forgot to mention, feel free.
We are deprecating some options, so just watch out for them. We are still backward supporting them till 1.0 release, but yeah, after 1.0, they are going to be deprecated. So please use the latest options that are available.
All right, that's a good call.
Yeah, always good to check out the release notes, of course, and every release. But thank you, Yaron, for this. This is this demo definitely shows stuff that's going to be really good for the operating side of Dapr for sure. We do have a question about the bulk get from Lynn about any thoughts on all keys or similar to return all the keys in the state store. So
yeah, that's a good idea. That can be another API that we put in, sure. And like always, open an issue and it shall be done, maybe, but open an issue.
Great. So we have a pretty packed agenda, so I'm going to swiftly move on to the next topic, which is Leon going to show us some of this stuff with MultiPubSub. So take it away, Leon.
Can you hear me?
Yes.
Can you hear me?
Yeah, we can.
Yes, we hear you.
Just making sure. Yeah, so, okay. So yeah, in the next release, there will be a new feature, which is MultiPubSub. which allows you to use multiple PubSubs in your apps. Previous to this, you only could use one. You could use more topics on that, but you only could use single PubSub. So with MultiPubSub, it's probably easiest just to show what this view would look like here. So this is the PubSub sample or quick start.
Wait,
And
Leon,
I
are you
edited it a
sharing your
little bit
screen?
to show what it would look like with MultiPubSub.
Leon,
So-
Leon, we don't see your screen.
I'm sorry, yeah, I'm not. Thank you. Yeah, just a second. Sorry about that. Can you see it now?
Yeah, now we see it. Great, thank you.
Okay, sorry. Yeah, so this is a modified sample app inside the samples repo called the Quick Starts repo. But here you can see that when the app comes up, Dapr calls Dapr/subscribe, and before you would return the topics and the route you want to listen to on the single PubSub that was declared. But now there's an additional field here, which is the name of the PubSub you would like to listen on. So in this case, it's saying that on the PubSub that I've called my service bus, I want to listen to, I want to subscribe to topic A, and when it happens, when there's an event there, I want you to call this route right here. This other one here is saying for the PubSub called my Redis and message on topic B, I want you to call this one. So if I were to show what this looks like, run this right here. One thing you'll notice from the output is it'll say briefly what you're listening for. So this is saying that it knows about PubSub called my service bus and this other one called my RIS, and then this one is subscribed to A and this one subscribed to topic B. So now if I send a message to my service bus topic A, I'll just do it through this, you should see that it gets received here. This is saying it came from A. We also print out the name of the PubSub it arrived on. Similarly, if I do it for the other one, sorry about that, then you should see a message from B. So using curl here, you can see that the publish API has changed a little bit. We've added an additional field after publish for the PubSub name, but that's just a small change. That's to indicate which PubSub it's actually going to. Now let me show what the component CMO look like. In this case, what this app has simply has two PubSub YAMLs declared. Here's the first one. This is the same as the default one the CLI creates when you do a Dapr init. I just renamed my Redis just for this example. So you can see that the Dapr will use metadata.name as the name of the PubSub in your code. So for example, it appears in this right here in the publish API, and in the app it appears in what you call the PubSub name. This is the second one. This is, we called it my service bus, and the type is service bus. And then the rest of the information goes down here. This is not the actual password. So yeah, that's a brief overview of MultiPubSub, which is coming in the next release, and hope that it makes usage more powerful. Thanks.
Great. And just thank you, Leon. This is great. This is another, I know, a pretty well requested feature. And we should just know that this is this is also a breaking change. Is that correct? That people should watch out for.
Yes, it's a breaking change. So there will have to be edits to the code. We'll make sure to document those carefully in the release notes about what needs to change.
Yeah, and this is part of our effort to kind of bring in the stuff that we know the community wants, and we want to get those breaking changes out of the way before version 1. So you're going to see some of those, as we mentioned, with the CLI and with this in the coming release, but it's definitely going to slow down and stabilize much more as we move forward. But this is all, you know, to enable these great features. So thank you, Leon. And I think with that, we'll move to some of the work on the SDKs. As you know, we're always trying to make the Dapr experience better for like the native developer in their own languages. And today we'll talk about the Python and Go that have seen some improvements. Maybe we can start with Python, Youngbu and Pruthvi, and then we'll talk about Go. So, Youngbu, I don't know if you're gonna present.
Yeah, I'm presenting now.
Great.
Okay,
Yeah,
so
the screen.
yeah. Hello everyone. We're gonna introduce new Python SDK improvements in this milestone. We have a lot of changes in Python SDK. And we have worked on how to improve the developer experience for our SDK. This is one of our efforts. So previously, when you write the Python SDK, Python application for Dapr, you first need to understand how to create a gRPC server, how to use gRPC clients. I mean, we think that this is kind of like a blocker for the developers who don't know how to create this gRPC server and clients. So we've tried to provide some of the decorators in this milestone and then make the developer experiences better. So I just want to give some example and and then compare the before and then after having these changes. So left side basically is this is a typical example to implement the service invocation server side. So you first need to create you first need to implement the app callback gRPC server like this way, and then also you need to implement the routing logic for each method for this case, and then you need to create a gRPC server and start a gRPC server, and there's some kind of the messaging loop here. So there are lots of boilerplate codes developer need to write. So we try to make this developing experience better. So we the right side basically is the new features in Python SDK. We provided some decorators to simplify these implementations. So basically, when you take a look at this one, you can just like create an app of the app and then just use the method decorator to define the new method service invocation, and then you can just write your code just like you write the Python method, and then that's it. And then you can just call the app.run, and then it will automatically create a server, gRPC server, and then start a gRPC server. And there's some kind of loop on that. So we encapsulated all these boilerplate codes, gRPC server boilerplate codes under this convenience layer of Python SDK. And this is an example of server-side code. And then the next example, basically, the client-side code. So this is an example, the simple like service invocation API example. So in order to like call the gRPC service invocation API, so you first need to load the environment variable to know what's the gRPC port, a Dapr gRPC port, and then you need to connect to the Dapr runtime, and then you need to construct the protobuf message like this way, and then call finally you can call the gRPC API like this. But it's really tricky to construct the protobuf message if you don't know exactly what arguments, what property you need to call the service and method. So we try to provide a like convenience layer on top of raw gRPC API. And for the right side, this is the new the Python SDK interface. So you can just create the Dapr client object and then use the like kind of the this wrapped API. And then, so for example, so right now you can just type it service invocation, then you can see the detailed help, like detailed information on how to use how to use the arguments and how to use service invocation with the examples. Yeah, we think that this way we can improve the developer experience a lot. And even if the developer don't know how to use gRPC, and they don't need to care about the gRPC API or like HTTP API, they can just use the Python SDK right now. And we are providing same the convenience layer for the PubSub and the binding. So you can take a look at the example later once we release the new API, new Python SDK. Any questions? And then if you don't have any questions, then Pruthi will show some cool demos with the Jupyter Notebook using Python SDK.
We actually have one question from Kasoon. Looks great. Does the implementation look similar to for gRPC streaming use cases as well?
Can I see the message?
Kasoon, we can also, you can unmute now if you want to add more details to your question.
Okay.
Be able to.
We don't support gRPC streaming, so.
Yeah, the Dapr gRPC APIs are gRPC Unary.
Yeah, it's a gRPC Unary. And then Joseph, what's the meaning of the no protobuf files?
So we do have protobuf, the protobuf services. You can find them in the Dapr repository under the directory of Dapr. So there you can find the protobuf files that you can use if you want to construct your own gRPC clients, just like you can see here on the left.
Yeah, you can still use the gRPC protobuf. And then also we just like providing convenience layer on top of the gRPC client. So. Okay, anything else? I think Pruthi will show some cool demo with the Jupyter Notebook with using Python SDK. Pruthi, can you share your screen?
Sure. Thanks, Changwu. Yeah. Let me know if you guys can see the screen.
Yeah, we see it, but I think if you can make it a little bigger, if there's a way to do that.
You mean the font?
Yeah, if possible.
Wait. Does it look good?
Yeah, much better. Thank you.
Okay. Okay. So yeah, let me introduce myself. So my name is Pruthvi, and I want to quickly demo how to use Jupyter Notebook along with Dapr as a sidecar, so that you'll be able to use all the features of the Jupyter Notebook interface, all while using the Dapr capabilities from within inside. Let me quickly write a simple program so that you'll able to know how to use the Python SDK to save state very easily with the latest Python SDK. So let's spin up the Dapr sidecar along with the Jupyter Notebook. This is the command to do that. So this part here is related to the Dapr commands. I'm just saying Dapr to use the gRPC protocol, and if in case it needs to talk to the app, it's going to use this port. And the app command is Jupyter Notebook, that's going to spin up a server that will serve a notebook. So yeah, this is the interface, Jupyter interface, and let me create a new Python file to quickly write a simple application that saves and gets state. And yeah, so with the new Python SDK, we have this Dapper clients, which you can import and use it to use all the Dapper APIs like state and binding, etc. Going to declare it as D, and yeah, just start writing the code. I'm going to declare a key here. Then I want to save a value, probably value 1, and my state, I have to use the store name as well. So I'm using the default component YAML that has a store name as state store. That's it. And then to save the state, I can just do d.save state and need to provide the state store name as the argument. I need to provide the key and value. That's it. So this is a way to save the state, but let's see if we can get the state and does it work actually. Let's see. d.get state, and I need to provide the same state store and key. Let's try to print this data. Save it and see. Yeah, so with the get state, I was able to retrieve the value that I've stored here using the save state API. And this is it. This is as simple as writing few lines of code to save, get, and whatever API that we provide in the Python SDK for Dapr.
So
I also,
a pretty question, just because I'm first time I see this demo and I'm really excited by it. This means that we can actually use Dapr to stream events right into the Jupyter notebook using bindings, for example?
Yes, we can do that. I'll also quickly demo that. I haven't prepared a demo for binding, but I've prepared one
I'm
for
just asking
PubSub.
for knowledge, yeah.
Yes, you can do that.
That's awesome.
Yeah. So basically it's running in Dapr as a sidecar. So you can do whatever you can with Dapr using the Jupyter interface. Okay. Anyone else have any doubts? Awesome.
This is great. This is really exciting. Great. That's definitely an environment that's going to be very useful for a lot of Python developers, for sure.
Right. It's very exciting. I'll also show you a demo how this can be used in the machine learning perspective. It will be really cool. Let me open this. So yeah. So for the purpose of showing the PubSub capability of Dapr, I'm going to demo a machine learning sample where I have two services. One service is simulating the publishing of training data to a particular PubSub component. And on the subscriber side, I'm going to train a neural net based on the data that's being published. Since we don't have much time, I'm just going to show the demo that I already prepared. Yeah, this is it. So I'm basically running a Jupyter server here, and I have this notebook that's basically creating some random data and converting that into a list and publishing to Dapr sidecar. So with the new MultiPubSub, we are having this PubSub name, which is returning the default component YAML files. So yeah, let's go ahead and run this. Yeah, as you can see, it's publishing values of X and Y as an array list. And let's run another application that's going to leverage this published data to train a neural net. So this is the command. Since we are going to use the app callback part of Dapr here, I'm definitely need to provide these options where Dapr is going to know that it's going to use gRPC protocol and this particular app port to talk to the service. Let's run this. It's going to spin up this one. And here you can see there's a notebook called train subscriber. Basically, there's a lot of code here, but essentially what it's doing is I've created a simple class that's a neural net with one single layer. And I have spun up I'm declaring a new Dapr server, app callback server here. And this is the decorator that we are providing with the new latest Python SDK, where you can just annotate any of your callable definitions with this annotation. So whenever a particular event is triggered with this particular data, it's going to call this definition here. And in this definition, what I'm doing is whenever a new batch of data is published by this publisher here, it's going to trigger this training method here. And it's basically doing some training which is unrelated to Dapr. If you know PyTorch, you're going to understand this code pretty easily. And here I'm training the model for an epoch count of 25 and just plotting a simple plot to show you the regression. So let's go ahead and run this one and see what we are getting here. This is the neural net that I've developed. Okay, let's restart the server. It's been open up since long, so yeah, let's run this.
And so when the training is complete, we can actually use Dapr, for example, to save the trained model or even publish it onto edge devices for scoring.
Right, true.
Cool. Yeah.
Yeah. So as you can see, this is the initial graph that's generated where the loss is very high, 3.99. But as the new data is coming in, it's getting better. The loss is going to decrease. So what's happening here is every time the publisher is going to publish this data, the subscriber is going to get the data and it's training the neural net. So yeah, this is the regression and this is the updated weights every time after one batch of training. So yeah, this is it. You can this way you can use any of Dapr capabilities with the Jupyter Notebook interface. And I know this will be very useful in data science, but I don't know much use cases. But one use case that I can think of is you can have any number of these publishers that's generating your training data. It could be a annotator that's annotating your images and publishing data, or it could be a simple web interface that a user is using to annotate and publish the data. And there could be a number of publishers. And on the subscriber side, you are going to subscribe to that particular topic. And once the batch of data you get, you're going to train your neural net. So yeah, let me know how this girl looks. And if you have any doubts, let me know.
This is very cool. And Pruthvi, thank you so much. I would love to actually see this in the sample repo or some version of this. I think this would be very useful. And if people can run it themselves, that would be great.
Sure.
We can discuss this after this. Yeah.
Okay.
Awesome. Thank you. So we're kind of at the final stretch. Let's let Mark talk about the Go SDK. I hope we'll have enough time for questions in the end, so we can come back to this really cool demo and other stuff we covered. So Mark, take it away.
Yeah, I'm not sure I can kind of follow this very easily, but we'll try it.
Hard act to follow. Yeah.
Yeah, it's an interactive UI. Can you see my screen?
Yeah.
And it's the browser window, right?
It is.
Okay. Yeah, this was super cool. So we've had Dapr Go SDK for quite some time now, and since protobufs and gRPC is kind of a first-class citizen in Go, it's pretty relatively easy to use that already. But we continue having these files generated for you, so you can easily import them from for your own kind of needs as required. But in order to kind of provide a very idiomatic experience for Go developers, we also wanted to provide this kind of abstraction layer, so that developers can really focus on productivity and writing applications for Dapr versus kind of wrestling with either gRPC transport planning or some of the primitives that our protobufs requires. So in the Go SDK, what we've done, we've created this abstraction layer that hides all the gRPC plumbing, like I said. So instead of, for example, creating a pointer to empty.empty in a protobuf, you just can use nil, which is kind of how you would naturally follow these some kind of things in a Go package. To import the Go client, just like with any other Go package, you just import this. Here's a simple example without actually any usage, but just to create that client, we provide a nice default specification for that that you can use to create a client that will automatically kind of preempt this for you with regards to the use resources underneath. When it goes out of scope, you can manually also close it. In situations where you want to start it on a specific port, we provide other constructors for both the client with a port as well as with an address, in case you want to use a specific IP on a host machine, or even connect to a remote API, Dapr API, as well as a client connection for gRPC if you want to go a little more advanced there. Just like with everything else, you can start, just like with other languages, you can start this using the Dapr Run example that you have already seen. You can run both the uncompiled Go code, just using the Go Run command, in addition to the Dapr Run command. You can also compile Go compiles into the machine code automatically, so you can run this very quickly. And if you combine it with like a two-phase build image build process inside of your image, you can really get down to very, very small OCI compatible images that then you can run in a Kubernetes, for example. So for usage, I'll come back to examples here in a second, but you will see various kind of primitive Go types for each one of the operations. So in this case, we have the state usage. Just like with most of the SDKs in Go, you will see the use of context, which will kind of provide a contextual execution. So instead of, for simple use cases, you see something like a save state, get state, and delete state that requires just one or two parameters, super easy to execute, easy to kind of invoke. For more complex use cases, we provide a fully fledged objects that you can kind of hydrate with the specific operations types, whether you want concurrency with last write or consistency strong or weak. You can provide metadata and other items. For ease of use, we also provide a way to save state multiple items at once. So this is an easy way, for example, for these either an array of objects or just a collection of items. For more complex use cases, I think Yaron already went over this, but for example, the get bulk items method is implemented here with the number of items. You have also support for transactional support that we've just implemented in the upcoming version of V010. So that's kind of true for each one of them, and we're going to go through each one of those one by one. But basically what it allows you to do is using the native Go interfaces and Go types, and very easily invoke the APIs for all the primitives for the full spectrum of the Dapr public API. In addition to that, what I want to also talk about is, let's maybe go first to the example, just because I think it's always good to have some real world examples that actually run. So for the client, we have an example that kind of exercises most of the SDK here. You can launch it as a single file. It will connect to the entire store, do all of this. You can kind of follow this yourself. If you're familiar with Go, this should feel very, very at home for you. But in addition to the API client in a Go SDK, what we also have done, we've created a way for you to, let me just scroll this, sorry for scrolling this multiple times. We also created some helper functions or helper utilities for creating the callback service. So in case of the first client we went over where your code invokes Dapr API, in this case, the service callback is in case where Dapr invokes methods on you. So what the three main use cases there, we'll go over those. We provide those for both gRPC and HTTP. So if you want to create a brand new service in HTTP and quickly implement one of those, you can do so. In gRPC, the exercise is pretty simple. So for example, the three main use cases we support there are event handling, service-to-service invocation, and when you're a target of binding invocation. So for something like event handling, you create a service now instead of a client. You add your own handler for a particular PubSub. We just went over the new additions in Dapr where we have support for multiple PubSubs. The topic on that PubSub in a simple handler. And this handler is not anything gRPC method or anything like that. It's a simple Go function that exposes an event that then you can capture an event on. Similarly, you will see exact same pattern for service invocation. Add service invocation handler, you provide the method, the handler, and in your handler, you can actually implement the logic. Similarly for binding. What that allows you to do is very quickly bootstrap these into a ready application and only focus on the user code, as in the logic that is unique to your application. So to take this slightly even further, what we have done, or I kind of put together a couple of examples. These are right now residing my own repository, but I think if there is interest, we can migrate them to the Dapr organization. We've created these templates, and these templates you've seen for each one of those patterns, both for gRPC and HTTP. What they allow you to do is using the GitHub template experience, which allows you to create a copy of the repository into your organization. You can create a template and using the simple kind of pattern that you already used to when you create a repository, so clone and CD into repository, and then just run a make in it, it will create, kind of initialize the entire stack for you. So with writing zero code, what you can do is you can actually go to this application. I'm going to show this in here. It will automatically create a stub for you that gives you a handler saying, just write your logic here. For processing events, that's simple as it gets. What that also allows you to do is you can, let me see if I can actually run this. So you can actually initiate that client locally and then send events to that code to kind of test it before even deploying to any environment. This allows you to very quickly, this kind of the local loop where you make changes, run it, test it, make changes, run it, test it until you're 100% happy. When you're happy with the operation, make image will automatically calculate everything, produce a super small rootless image that will be built for you and publish automatically into your Docker Hub. You can use different repositories by changing a couple of environment variables. This should be done pretty quickly. I'm not gonna follow through this because you've seen this screen multiple times. But what I wanna show is how small those images are when they're finished. Now, this is gonna take a while. We're talking about 8 megs in this case, including a full-blown application that has all the components from Dapr in the SDK, but also kind of a local local gRPC server and all the dependency. In addition to that, this template includes other goodness, like for example, a deployment file that's automatically configured for you for the Kubernetes deployment. It will include the appropriate name for your service when it's created with all the right ports, and the image once you publish, in case this will be derived from the init function when you first create it, and will also include some sample components that you can create. So very quickly from nothing to an application running with a pretty good set of practices that are following the Go patterns, you can get there pretty quickly. These templates right now are for gRPC event subscriber, event service to service invocation, and HTTP subscriber, and we have also like a binding for cron executing on a certain schedule. These are super easy to use. Definitely love to hear from you if these are valuable. If they are, we definitely want to provide some better experience for those inside of the official Dapr repository versus my personal repo, so to speak. So right now, until Dapr 0.10 lands, you can just use the current tag, which is 0.8, which will give you compatibility with the current version of Dapr. As soon as the new version lands, we'll update the tag. And when you do an import, you'll automatically pull the appropriate version. That's pretty much it.
Wow.
Again, we hope you find this helpful. And if you see some kind of gaps or needs, please open issues. And there's already a few of those out there, and we'll try to address them.
Thank you, Mark. So we're coming really close to the top of the hour. I do want to talk a little bit about what we did with the samples recently, and hopefully, if you have more questions, we can stay a little bit over, or just feel free to use Gitter or GitHub as usual. Let me share my screen real quick. I'm sure most of you have seen or even have gone through the samples at the Dapr repos. We've got, we used to have the samples repo that had everything in it. It had a bunch of numbered samples. I'm sure a lot of you have done them because this was the part of the getting started experience, which we're still evolving. What we did is actually split that into 2 repos, and I can explain a little bit of the rationale, but everything, most of those actually are now in a repo called Quick Starts, which is where we want to have very simple code samples that are really kind of geared towards people who are newbies to Dapr and want to just get started really easily and see different capabilities, building blocks. These, by the way, as before, are tagged by the version of the runtime that they've been validated on. So we actually validate this every release, make sure that they work and that people who are coming in can run them and everything works. The problem with this approach was that we do find there is value in adding more samples for more either niche or advanced use cases, but then the burden of validating them every release gets higher, and plus it becomes a little confusing for people that are just coming into this experience. So what we did is, well, this is kind of, we're gonna keep it pretty tight. We actually have another repository which has the name samples. There was something that might be a little confusing here. We actually changed the old samples to be called Quick Starts, and this is a different one. The reason is that we want to keep those tags and that history in GitHub. But right now, the one that's named samples is actually a place where we have all these other, mostly community contributed samples that either show an application, and this includes the Twitter sentiment processor that we showed in build, and as well as some things like how to do hello world without Docker, and recently even we just added this even this morning. And there's a few more coming in. So a little bit about the differences. So if you have a piece of code that you would like to contribute as a sample, it would most likely go in here. This repository is not tagged. We do not guarantee that it works for every version. But what we do say is we kind of say which version it's been last validated with, and a little bit more information on kind of what languages and what environment it involves. And you can see that actually for this one, even there's already a pull request for I think it's this one, that includes just bringing it up to speed to 0.8 and 0.9 for some of the things that have changed since. So that's how we're kind of going to manage these samples. So it's going to be kind of a best effort. If you see something that's useful and you want to update it to the recent sample, to the recent runtime, that's a great way to contribute. If you want to add more samples to things that you think would be beneficial for the community, this is the place to do it. At the same time, the quick starts, we're going to keep them a little more tight, a little more small. We're going to evolve them probably to a better getting started experience, but they're going to mostly stay like this, just so they're kind of like a very well concise way to do the getting started for people. So I hope it's not too confusing. There's actually an issue here that kind of explains all this, and I can share that as well after this. So we're over time.
I think we might want to go
so,
to Q&A because people are starting to drop.
Yeah, so thank you for joining, everyone. If you have more questions, we're happy to stay a little over or engage with us in Gitter or over GitHub. We didn't have a packed agenda today, so apologies we don't have more time for discussion. So I'm not seeing anything on the chat. Oh, any books coming out? So there's actually a few things we're working on. Yaron, I know there's something you can comment on this, maybe.
Actually, is Haishi here? Because we're co-authors. Maybe Hashi wants to chime in.
I think I saw he was at some point. Yeah, I think he's still here.
And things like Amazon Free RTOS is making it much, much easier. Now, obviously.
Yeah. I don't know. I think he is. Okay. Yeah, so there's a few things coming that I know Yaron is a co-author, but also we're also working with some teams actually at Microsoft to perhaps do something as well. But stay tuned for that.
So I'll just give some more info. So Haishi and I are co-authored the book that's coming out in September. You can find it on Amazon right now. It's with O'Reilly. It's called Learning Dapper. And yeah, that's we hope that's going to be a good book for you.
Yeah, and some more stuff is probably going to come out towards the big release of version 1.0. Okay, with that, let's close this one. Thank you so much, and we'll have another one in 2 weeks. I will upload this to our YouTube channel as always. So thank you for joining.